Hey everybody, it's Ms.C, and today we are going to be switching from natural resources, but keeping with the natural environment, and we are going to be talking about weather. So to start talking about weather today, we are going to be talking about the air and our atmosphere that surrounds the Earth. So turn to page 260 in your Fusion book. And let's start reading. Up in the air. Quick. Describe today's weather. Is it cold and windy? Warm and dry? Many things do depend on the weather. What is the weather? So today the weather, here where I am, it was actually pretty nice. It was like in the 50s. It was still a little cold. It was mostly dry. I would not say that the air was humid, but the sun was out and it was really beautiful. So think about what the weather was like where you were today. Earth's atmosphere protects living things from the sun's harmful ultraviolet rays and shields Earth from space debris. It is about 600 kilometers or 372 miles thick, which seems very thick. However, in comparison with the rest of the Earth, the atmosphere is actually quite thin. The atmosphere is a mixture of gases. It is mostly made up of nitrogen and oxygen. The condition of the atmosphere at a given place and time is called weather. So we know now the definition of weather. It is the condition of the atmosphere at a given place and time. Weather takes place in the layer of the atmosphere closest to Earth's surface. Without the movement of gases in the atmosphere, there would be no weather, right? So the movement of gases creates weather in our atmosphere. Many factors, including air temperature, humidity, and air pressure, help us describe the weather of a place. Air temperature is how warm or cool the air is around us. Air temperature affects how much moisture is in the air. The air temperature also affects how we dress and what we do outside. Humidity is the amount of water vapor in the air. When the air feels very dry, we have low humidity. So in the winter, the air is very dry. Have you noticed that your lips will crack, your hands might get really dry, your skin starts to dry out? That's because there is low humidity in the air. The air is not moist. It doesn't have water vapor in it really. So it is dry. When the air feels damp, then we have high humidity. High humidity also can affect another weather factor, precipitation. Precipitation is water that falls back to Earth. Depending on air temperature, precipitation falls as rain, snow, sleet, or hail. So there are examples of precipitation. Air pressure is the weight of the atmosphere pressing down on Earth's surface. Air temperature and humidity both affect air pressure. Changes in pressure usually brings changes in weather. So now we have a graph that we are going to fill out here. It says do the math. So here's our situation. A student recorded the temperature of the air at 3 times during the day. 50 degrees at 8 a.m., 62 degrees Fahrenheit at 12 p.m., and 56 degrees Fahrenheit at 4 p.m. So they want us to graph the data. So I want to show you something quickly. This little circle next to the 50 is a degree symbol. The F next to it stands for Fahrenheit. So the United States, we use a different system than the rest of the world, and we measure our temperature in Fahrenheit. Okay, so we have 50 degrees at 8 a.m. I'm going to plot a point up above 8 at 50 degrees, 62 degrees at 12. I'm going to go to 12, and I know that there are no lines for 62. We have 50, 55, 60, and 65. Here's 12 p.m. Where should I put my next point? Somewhere here. Not directly on this line because that would be 60 degrees and that would be inaccurate. They said it was 62 degrees at 12 p.m. So I would probably put it somewhere right here, somewhere in the middle, a little bit farther away from 65, because is 62 closer to 60 or 65? 62 is closer to 60. So I'm going to put it closer to this line. Next, I'm going to plot the temperature at 4 p.m. And at 4 p.m., it was 56 degrees Fahrenheit. So it went up and then it went back down as the sun started to go down. So at 4 p.m., 56, so I know that's just going to be a tiny little bit above that line where it says 55. So here are our points plotted. And now we're going to connect them to make a line graph. And now if I wanted this to look really, really nice, I would use a straight edge, but I don't have one with me right now. So my lines aren't super straight, but we see that the temperature went up in the middle of the day and then started to go right back down towards the end of the day. So I can conclude, it asks at the bottom, what can you conclude about that? We're drawing a conclusion, we're making an inference. We can conclude that the temperature goes down as the sun goes down, because when is the sun highest in the sky at what time? At 12 o'clock in the middle of the day. So we know after the middle of the day, the sun starts to set again. What time does the sun usually set right now? I can check my phone, actually. All of our smartphones have the weather app. That sunset is at 7:30. So we know that 4 p.m. the sun is starting to set, starting to go down. So the temperature is going down. Page 62, under pressure. Have you heard of meteorologists talk about high and low pressure? High and low pressure describe the air around you. You can't feel the atmosphere pressing down on you, but it is. Air pressure is the measure of the weight of the atmosphere on Earth's surface. Changes in air pressure bring changes in weather. A barometer is a weather instrument used to measure changes in air pressure. Temperature, humidity, and distance above sea level all affect air pressure. Cold air is denser than warm air, which means air pressure is higher in cold areas than in warm areas. I'm going to underline that because that just explained a lot to me. I'm going to underline cold air is denser than warm air, which means air pressure is higher in cold areas than in warm areas. A volume of humid air is less dense than an equal volume of dry air. As a result, humid air has lower air pressure. I'm going to underline that. It has lower air pressure than dry air. Most air particles are found closer to Earth's surface. Air pressure decreases as elevation or distance above sea level increases. So here we have our barometer that meteorologists use as a tool to measure air pressure. So we have a pan of liquid mercury here, and we know now that if the air is very cold, then it is going to be more dense. It is going to push down on this pan of mercury that is then going to be pushed up into the tube, and we can then measure how much air pressure there is. So air pressure is higher at the base of a mountain than at its top. The force of gravity holds most air particles close to Earth's surface. So when you climb a mountain, the higher you go, the atmosphere thins and air pressure decreases. So we have our two barometers here, and they want us to fill them in, show where the mercury would be pushed up. So at the base of the mountain, the air pressure is going to be higher. So I am going to put this mercury all the way up to the top and color it in. It's much closer to the top than the one for the mountain is going to be, because it's going to be less air pressure up there because the atmosphere is much thinner. So now we know that there's a lot more going on in the air than we think about. When we go outside, the weather is dependent on many different things. And now we know that the weather is dependent on humidity in the air. That is the amount of water vapor in the air. It is dependent on air pressure in the atmosphere. And air pressure is a mixture of air temperature and air humidity. And we know a lot more about air pressure now and about our atmosphere, and that if we wanted to figure out what the air pressure was, we would just buy a barometer. So stay tuned, fill out the exit ticket, because tomorrow we are going to continue to talk about weather, and we're going to talk about those big fluffy things up in the sky. We're going to talk about clouds. All right, I hope everybody has a great day. Stay safe, stay healthy, and I'll see you tomorrow.